Hello, my name is John Jorgensen, and welcome to my channel, John on Tech. Today I'm going to be speaking about monolithic architecture versus microservices architecture. So on the screen right now, I have a picture of a typical monolithic architecture for a web application. So the user will use the web browser to access this, and then it will be forwarded into a web address, which then will be hosting a customer service, a product service, and a cart service in this example. So the traffic then will go from the web browser and then will be directed into the various or the three different modules, depending on where the user is in the web experience and where it is before the user is before checking out then with the cart service. So on the back end here, we have a database, and it doesn't really matter which database it is. Applications will typically be the same architectural wise, and it doesn't really matter which language is being used for implementation either. And these days, you will find that this has typically single page applications and to provide a good web experience for the user. Now, the difference here between a monolithic architecture and a microservices architecture is in the middle here, where we have an application that is then based on one code base, and everything is together in one source management system typically. So what is the implication of having this, which is traditionally how applications are built? So when these are small, when the application is small, it is easy because it's easy to develop, easy to deploy, easy to enhance, and easy to scale. The reason for this is because the code base is small. We can develop tests, unit integration tests. We can easily deploy it. There is really not a lot of problems. The challenge becomes when the application grows large, which will, of course, happen with any application of any meaning. Any application that provides real value to customers will typically grow large over time. And so typically what happens then is that the application becomes hard to enhance, hard to deploy, and hard to scale. So reasons for this is that the code base is now so large, and we may not have the original developer still maintaining the code and enhancing the code. So because of the size of the application, developers are starting to become fearful of making changes, enhancements to the application because they are afraid of breaking it. Also, it's hard to deploy because it's large, and therefore, if any part of the application has an issue, we have to redeploy. It's hard to test because there are so many use cases that go through the application. And also, it's hard to scale it because it is typically developed just to be a single instance, so that when your customer base increases, especially for web application, if you have a popular site, then typically you'll get a lot of traffic. And now what will happen is that you have bottlenecks in your application, but you can't really break it up because everything is just one code base. So as a result of this, the application as a whole is brittle, is susceptible to failure, and new deployments becomes cumbersome and time consuming, and you typically are not going to be flexible in your ability to deploy, and it's hard to deploy individual services separately. Well, you cannot do it because everything is just one big application. So for instance, if you have to make changes in your customer service component, you even if you make changes here, it can affect over here, and it can affect over here. so you can have side effects of what with the changes that you have in the customer service module over in your product service and the cart service. So well, what you have to do is to run the entire unit test code base on the code base, and you have to do a complete application testing to be as sure as possible that you have not broken anything before putting this into production. You're also tied to one language and one architecture. So these are disadvantages of a monolithic architecture, and also the driving forces why microservices came about. So if we look at microservices architecture, this is totally different. And we see there are a lot more components here, and things are then broken up into individual parts and pieces. Okay, so we find the customer service, the product service, and the cart service are again the main modules of the application and still present, but now they are within the framework of a microservice. This means that each individual component is more loosely deployed, loosely coupled to each other, and therefore they can be deployed separately. So to start at the on the left side here, we have an application client. So this then typically then is the browser web client, and this again is a web service. So you would have authentication that goes into the authentication service to make sure that the user trying to log on is authorized for access. You have an IPA interface that then controls traffic into the individual components. And so then you are into the microservices architecture from the API interface. Over here, we have resource management. And resource management, that means that the individual components are managed so that if the customer service goes down, then there will be a new one spun up, and you can have duplicates of each of these. So this increases your fault tolerance. Further down here, we have also a content delivery network. So this is typically used for static content. So things that doesn't have to go through any of these three modules up here, because it's just static HTML or maybe some JavaScript or that is rendering the page or part of the page. So therefore it can be separated out. Now the content delivery network is then placed close to the physically close to the client. So it is provides for a lower latency when accessing that physical content. So it improves the performance of the application. That's the only reason for employing a content delivery network. And there are many different companies that can provide that for you if that's what you're after. So as mentioned, the authentication service is used then to authenticate the user. Username, password is one typical way to do this, or more sophisticated, you can have two-factor identification or authentication. So the API interface is then exposing the web address and a common interface routing traffic to the individual services back here, as we spoke about earlier. So the resource management piece is that ensuring that the high availability so that the microservices component are available. And also, very importantly, now we can scale. Individual components can be scaled up. So this is one of the advantages here. So say that you have high traffic for your customer service component, then you can have 2, 3, 4, 5 different instances of that. You can have a router service in front of it here, and then you can scale up as needed. So another advantage is that now these services are loosely coupled so that you can deploy them individually. You don't have to deploy everything at the same time. You can deploy the customer service component, the product service component, and the cart service component all independently of each other. Typically, for this kind of architecture, the components themselves are then connected to each other with RESTful web services. And another advantage of having these being individual components and then isolated from each other with an API, such as a RESTful web service, is that they can be developed in individual different languages. So Python, Java, Go, whatnot, you can have all of these implemented, and then you can assign different teams to work on each of these different components. So it provides a lot more flexibility. Now we have also, as the last point here, we have now provided for an opportunity, an architecture where we can have much smaller code bases, because each of these applications, they access separately. They could be managed typically nowadays by different Git repositories, and each team working on these. So you can have team A, team B, team C working on these different components, and they can then have varying deployment schedules. And because everything is controlled through APIs, all you have to be concerned about when deploying, say, a new instance of the customer service application component, only thing you have to be concerned about is now that the API interface between the customer service and the product service remains stable, and so that you are not making any changes that will then cause changes into the product service. So you have a well-defined interface, and you can be sure that your changes that you are making can be well tested, and they can be isolated to that particular component. And so this provides for a lot more flexibility. The speed of application development increases because of the advantages then of a smaller code base. So this is all I had today, architecture. Thank you, and if you like this video, please subscribe, like, and share.